Alright, ladies and gentlemen, so I know some of you are having a little anxiety about these vector problems. So what I've done is I've made a little sample here. Let's go through it. Madeline is playing in the backyard. She runs 5 meters south, turns and runs 5 meters east of south at 36.9 degrees. Then runs west 6 meters, loses her shoe and runs 4 meters north to the door. What is her overall displacement? I've been harping on you guys that step number one is to draw out the problem. So first things first, 5 meters south. And then we're going to draw 5 meters to the east of south. So if you're going to draw something that's to the east of south, you should have an imaginary line going south, and then draw your vector off to the side of that line. So it's 5 meters. 5 meters east of south. So here's south. Go to the east side of south. 36.9 degrees. Oops, make that better. Then she goes and runs 6 meters to the west. 6 meters to the west. And then finishes off by running 4 meters to the north. Meters. Now, your instinct is to say, oh, there's a triangle, there's a rectangle. Okay, that's nice and all. But we have to treat this vector, that one, and this one all as 4 completely separate entities. So, looking at it here, we need to break this one down into its components. So I'm going to say the sine of 36.9 degrees times the hypotenuse of 5 meters is going to equal the opposite, otherwise known in this triangle as, I'm going to call it x, and then 5 meters times the cosine of 36.9 degrees is going to equal the vector known as y, x and y. Now, conveniently, y, when you put it in your calculator, comes out to 4 meters, and x comes out to 3 meters. So 4 meters, 3 meters. Now that you have that done, you have this here. I'll do my little mini rough sketch. 5, 4, 3, 6, 4. But that's a little cluttered, and I want to resketch over here how I draw it now. So I go down by 5, down by 4, up by 4, a displacement of overall 5. And then we go, because you know his tail, east 3, west 6. So if I have 5 plus 4 minus this 4, and then I have 3 and a 6, but it's maybe negative 3 plus 6. This gives me 5 by 3. Overall, I am 5 and 3 over. So I really have this here, 5 and 3. 5 by 3. And then you got to do a little bit of Pythagorean theorem, where you have 3 squared plus 5 squared equals c squared. Well, that's 9, and 25 equals 34 equals c squared. And when you square root that, you get 5.83 meters. Number one thing is this. Identify where the vector goes. Break it into pieces. Once things are in x's and y's, you can add up your x's and you can add up your y's and get your overall displacement either way.